Hello and welcome back to another Toby part tutorial. This one effectively by request, as Mr. Tutol himself said he liked to see these, so thanks for the shout out and happy to oblige. So I will right away go over how I would do this part, which is for the most part the same way. So let's dive right in. So I would start the same way using a sketch on the front plane. One thing I really like to do is to use lines as construction geometry instead of adding dimensions after the fact, because you can use the auto dimension to quickly create everything you need without changing tools. So I like doing it that way. So this is the 170/2. This goes down to here. I'm gonna not worry about the angle for now. And I'm actually gonna include this just to have it as construction geometry. Don't know that dimension, I don't think, no, but we do know that this is 150/2 or 75. And then we're just gonna add this one dimension here for the 60 degrees. And that's it for this sketch. Now we're going to go into sheet metal, do an extrude as well. Same thing, change the size. The first difference is that I'm only going to go to 40, and rather than make it oversized and cut it out, which does work, I'm going to use something a little bit different. But otherwise that's what I'm going to do. So the way I'm going to do that, so I made this just a 40 to here, and now we need to do this 26-degree angle, or really 13-degree flare out. And one really easy way to do this in Onshape is to use the move face, which in sheet metal is just a really convenient tool because it works so well. So this is an easy way to just add this, I guess, 13-degree angle here. And that gives you your base shape, and you have to do this first before you do that bottom flange. So even though I included this sketch down here, if you try to do this move face after you create this, you're left with a little bit of a mess you have to clean up. So it's easier to do the flange after. So I'm with Toby here. And this one, so outer is what you want, because that's the original flange went to that vertex. So if you pick the outer, it will use this virtual sharp as the end of the flange. And one thing you can do is, instead of just putting 120 for the angle, you can actually use align to geometry and pick, for example, the top plane, and that will set the angle. And then for the end condition, since I put in layout sketch, I can just go up to and use that point. But using up to with offset to the right plane is also a really good way of doing it. So full marks for that one. All right, so there's that. Now let's look at that fun. Let's check that we're doing well here. We've got 56, so we've got that correct flange length at the bottom, as we expect. Now this is where it gets a little bit interesting with that slot. There's actually a bunch of different ways you could do it, but one interesting thing is, I don't think I would do it in 2 steps with the 2 cuts. I mean, it works, but I've got a few other ideas. Sorry, I'm losing my train of thought a little bit here. Right, I need that dimension. One option, this is 140, so 70. That does not look right. Apparently I messed something up. Okay. This is, this was 170/2. There we go. That looks better. So anyway, so one option, cut through. One option would be cut all the way through and then add a tab to the bottom flange. So cut all the way through the bottom flange, or even put the cut before that flange and then add a tab to close that up again, which to add basically this little region after the fact. Another option would be to come in from the side and do a cut, you know, like this, into the part from the front plane, and then add fillets to the corners. These would both work. Not that interesting. I did try to do a lofted cut, but it doesn't, actually I can show what happens, is if you try to do, it almost works, so I guess it's kind of interesting that way. And we just need a dimension of 190/2, which is 95. So this is actually kind of fun. If you try to do a lofted cut between this and this, you can see what happens here is it works well here because Onshape always does normal cuts on sheet metal, but for whatever reason, I guess for consistency, it always starts from the same global side, so from the top surface. And I tried to reverse. I tried a bunch of things that you always get the same result. I tried switching the order of the two profiles to see if it would change which one it got right, but it just doesn't change anything. And one way I thought I was going to be able to get it to behave is to change the end conditions. By setting this normal, it looks like it's going to do it, but then it's actually still off. And side tip, something that can be really useful to understand what's going on here is here you're just seeing the preview of the result, but because the extrude function in Onshape it's the same for creating a new or adding or removing, you can quickly switch to new to get a preview of what's actually happening. So this actually shows you what it's trying to remove, and that helps understand why it's almost right but not quite. So here it starts to cut normal here, but it actually uses this intersection point to figure out where to remove the material, which is always going to be off. I mean, you can get it very close if you increase the tangent magnitude, the normal magnitude, but that's a bit of a hack. So anyway, using this to preview though is a useful feature when you're trying to understand why something is not looking like what you expect. So troubleshooting any cut, any remove problems, try to switch it to new to see what's going on, is a tip of the day. Anyway, not going to do that way. Going to get rid of this. One actually pretty good way of doing this is to basically draw the path and use a sweep. So starting from here, like, okay, this needs to go here, and then down here and down here. That should probably be normal. And it actually doesn't really matter where this point is, because all you want to do is cut right through down here. So you need this section to be cut normal, and then that same profile you want to cut through here along this. What you're doing in between doesn't actually matter. You can even probably remove this, and you could have it like this, or I picked up, or make it even have that horizontal. It doesn't actually matter. I like fully defined, so I'm just gonna put it here, or actually that looks wrong. I'm just gonna leave it like this, which is kind of the ideal sweep profile. And then if you try this, you can do a sweep from this along here, and you can see it fails because it's self-intersecting. But if you check the keep profile orientation, then everything's good. So I think this might be one way I would do this. That works well. You still need two sketches, but I do think it's a little bit simpler and cleaner than doing two cuts from both the two ends. But how I would really do it, which I think is the best option, is to actually do it in the flat. And the way this works is I'm going to use my lines as a construction tool again. So this is my 140 2. This next section that is the slot, I don't know what it is. And I just want to make sure I don't pick up a midpoint or anything that I don't want. And then if I go to here, this dimension, which is really from the center point here to here, it's actually driven by this 190 and the 150. And it's really 190 over 2 minus 150 over 2 is the distance between the edge of that flange and here. So I can say this is 190 over 2 minus 150 over 2, which works out to 20. And then just make this into a slot, 24, extrude cut that, and this is actually the easiest way of doing this, I find, personally. So that's how I would do it. But the 2-cut option does work, but this is a cleaner one way of doing it. All right, next up, let's do that side flange, which is totally, I'm going to do exactly the same way, basically, at least for the start. So angle is 75, and we do want partial flange. And really, partial flange, what you're doing is you're saying how much you want to remove. So default flange is the whole length, and partial, you're just removing part of it. So here I'm removing, 3.5 millimeters from this end, flipping the arrow removes from the other end. And then I'm saying I'm going to remove from this end, and I'm going to remove up to the right plane with an offset. So I'm going to remove from this end up to here with an offset of 55. So that's how you think through the partial flange, which can be a little bit confusing because of the way you have to get used to the naming convention and what it means. And that flips the offset, and obviously if the offset is the other side, you're left with nothing, so it's gonna fail. But at least the preview kind of shows you what it's trying to do. Anyway, this is how we do this flange. Oh, and so the next interesting part is the length. And actually, before I'm going to go into that, I'm going to do a quick demonstration by one thing I want. Oh yeah, there's something I want to talk about because that's actually kind of interesting. So I'm going to just do a sketch here, then do a variable to show the length. And actually, one really simple way in Onshape, whenever you use the measure tool, you have this little button, and if you click it, it will create a variable of the thing you just measured. And the reason I want to show this, there's a reason. Let me just hide the flat. It's getting a bit busy. Is the if I hit final, I can see that it's rebuilding the sketch in the variable, and you can see that obviously it agrees with the length of my blind distance. But what I wanted to really talk about is the fact that in Onshape, it doesn't matter which edge you pick. So I pick this edge or this edge. It actually lets me pick both. You get the exact same result. So the way the flange goes doesn't matter on which of these two edges you pick. In fact, you can even pick just a face, and it will create a flange starting from here. So it's good and bad. It means there's no you don't have control of what's going to happen to the flange by picking one edge or the other, but you also don't get different results. It doesn't matter is the answer. But the flip side of that is that the length, the blind length, or the length of the flange is always to the virtual sharp. And there's one case where it can be a bit weird, is when you're doing acute angles, you end up with what looks like a really short flange, and you think it's wrong sometimes, because in this example, this flange, it's like, how is that 30 millimeters? But the 30 millimeters is to this point here, the virtual. So if you have a big radius and thin material, it starts looking really weird when you get into big angles, and it will fail at some point and you might wonder why. So either back out the angle, or increase the length, or what I would do here is just do it up to entity, and it doesn't even really matter what you pick, but just picking the top plane. Right, sorry, oh, my bad. That's the end condition, not the partial flange end condition is what I was changing. So, but if you pick the top plane, then it doesn't matter. It's always going to figure it out, whatever the angle. Anyway, I'm kind of rambling on, but the key point I wanted to make was doesn't matter what you pick for your flange, it will calculate the length always to the virtual sharp. In this case, anyway, what we're trying to do is get a specific length between here and here, and the best way to do this is actually with a move face, because you can just do move this face up to entity. It's kind of interesting because sometimes Onshape uses up to entity and gives you an offset checkbox, or like the partial flange, it's up to entity with the offset as an option in here, so they're not super consistent. And here you can see by this arrow it's trying to go the other way. But key point is by doing it this way, it will always be exactly 20 millimeters away, regardless of even the length. And the nice thing with the offset like this, the move face, is that it doesn't matter. It handles both cases where this is longer, so if I hit final, the move face happens and it shortens it, or even if it gets shorter, the move face is always going to move to a certain distance from this vertex that I picked. So whether the flange ends up being shorter or longer, it doesn't matter, it figures it out basically. Before the move face, that's what it looks like. This is longer, but even if I had the flange longer, the same move face feature can also shorten it the same way. Anyway, I'm gonna clean that up. Just general fun facts. Gonna add that 14 millimeter fillet here before I forget. And now, kind of, I guess we're getting there. Last features. So this is actually a 30 by 30 rectangle. If you hold Alt while you draw a rectangle, it makes it into a square. Adds an equal relationship, which can be a nice little shortcut. And this is 15. Now, one thing I'd like to do here is just creating a cutout. And I find that, yeah, you can use the hold line condition and then the partial flange. You can do it, you know, the way Toby did it works, but it can be a little bit more hit and miss in terms of getting all the options right. And I like to to include the tab directly in here. And I mean, it doesn't really matter, you either do just the radius or I like to do radius plus thickness, which in this case is 10, and then add a 5 millimeter dimension here, and then just do a cut to remove this material. And then I find it makes it clear, like when it's dimensioned like this, it makes it very clear what this flange is going to do. If I pick, since I did the thickness plus radius, I want the outer limit, and then I know I've got my 5 millimeters in the sketch. I find this a little bit easier to get right than messing with the partial flange and all that, but either way works. And the last thing I would do here is I probably should have, considering sketch 1 was kind of a layout, I could have added something at 85 as a reference, just to use up to, because I don't think, actually I can try, but I don't think it works. If I was trying to do up to this with an offset of 85, I don't actually think it's going to work, because the flange is starting this way and I'm asking it to go up to this surface, which is behind, it's the wrong way, even though by the time you add the offset, they would be the right way. It does get confused. But anyway, I would pick up to entity and with a reference in the sketch like I did for this one. That might be a cleaner way to be sure, but again, it doesn't matter what you pick here. I'm gonna pick the face, top edge, bottom edge, you get the same thing, always virtual sharp. So you can do the math here and say you want, you know, 85 minus 65, which is to the top. So you have to add back the thickness, which is 4 millimeters, to get your overall height to be the 85 target. And then we need a hole. Put it here, 9 millimeter distance from the top plane. That works. Picking it from here, but that's a good tip. You can also pick the origin. Works the same way, and that is 77. And we're going to do a remove. And we just need a fillet here, and we are basically done. By the way, full marks for only doing a quarter of the model. I'm always surprised when I see people, especially in speed modeling, doing multiple mirrors in the sketches, multiple mirrors in features, when really just model half of the quarter of the part and mirror at the end. The time it takes to add a mirror feature is pretty quick, so it's quick to burn through that time. One thing to note is, I know SolidWorks for sheet metal parts requires you to pick a face of the sheet metal. Onshape doesn't actually care. You can pick planes or whatever, so you don't actually need to pick a specific face of the actual sheet metal. And let's see if we got it right. Oh yeah, there's actually one more thing. 368. That is correct. There's one more thing I wanted to note, and that's more of that's really a design intent kind of thing, and not about this drawing or anything. But I noticed that the 75 degrees and then the 26 degrees result in these two faces being almost parallel but not quite, and that does bother me a little bit. And I understand why the drawing's that way, because that would be a bit confusing to try and do it that way, even though it's probably very close to the same part. But in Onshape, it would actually be really easy to make this exactly parallel. And the way I would do this is I would actually take this move face after the flange, which would give you that, but then I would change it to also move that face down here. But obviously this is not what you want anymore, but we just need a different axis to rotate. And the good thing with Onshape is you can use a mate connector and basically create an axis wherever you want on the fly. So I'm going to pick I want this point to not move, so I want to rotate around here, but I don't want to rotate, it's going to rotate around the Z axis. I'm going to do a bigger angle to better show this, which is not what I want, but it's a mate connector, so I can just say realign the primary axis to, say, the right plane, and now you can do it this way, and I can do 15, which is, you know, the angle of that flange, the 75, 90 minus 75 is 15. And now if I do that, now these two are exactly parallel, which just feels better. Now obviously this angle is not exactly 13 anymore, but now these two faces are parallel. And all this with just one move face feature, no construction geometry needed, because you can do it all on the fly with just one mate connector. So anyway, that's another little tip on what you can do with the move face feature, which works extremely well in sheet metal and Onshape. not just in sheet metal, but in sheet metal it handles, you don't have to worry about picking both faces or whatever. It just does it really well. And actually I don't know how much that changes the mass. It's still within tolerance actually, interestingly enough. Anyway, I think that's all I wanted to say. Yeah. Oh, and if you were to do it this way, you don't need to do that flange separately. You could include it in the in that first feature, that first extrude. So you could add this in here, suppress this one, basically, and I'm gonna break a couple things, but you get the idea. If the design intent was to have this face be exactly parallel to this flange, then that's how I would do it, rather than with the 26 degree, which obviously would not remain the same if, say, if you change this to, you know, some other angle, this will keep it the same regardless. They will remain parallel, which is kind of cool. Anyway, probably enough rambling for today. Hope that's interesting to at least some of you guys, and catch you next time.